Okay, so this video is just going to go over really quick how to do the pH activity. So you can pull up your worksheet here, and here's the link that will take you to the simulation. So what you're going to be doing is you're just kind of going to be examining the relationship between the concentration of hydroxide ions, OH, and the concentration of H+, which is actually technically H3O. So you can move these around as you need to. Sometimes it's easier to move these till you get closer to the number that you need up here and then use the arrows. It saves you a little bit of time. But so for instance, for this one it says you want to adjust the pH to the following and record these concentrations of hydrogen ions and hydroxide ions. So what we want to do is we want to move the thing to a pH of 1. And you should know at this point that from your lecture videos that, the pH scale is 1 through 14. So 1 through 6 are considered acids, 7 is neutral, and 8 through 14 are considered bases. And so we're really going to be focused on these exponents here. So let's move this up here. So we'll do the first example together. So here's a pH of 1. So you're going to kind of toggle this until you get a pH of 1. I like clicking this box here. You don't need to, but I like it. It's kind of a visual so that you can see all of the H pluses are red and all of the hydroxides are in blue. And so we know that acids have a lot more H pluses than they do hydroxides. So you would know just by looking at this that this should be an acid because there's a lot more blue. If we move this up to a base, then you see we have a lot more hydroxides, which is typical of a base. But going back to our 1, so here's a pH of 1, and so it's asking you to write the concentrations down in the table. So the concentration of H plus is right here. It's 1.0 times 10 to the negative 1. And so you would just write that here on the table. Okay. The concentration of OH is 1.0 times 10 to the negative 13th. So now remember that exponents are, you would move the decimal point. So this is actually 0.00000, 13 zeros, 1. So a very small amount of hydroxide ions. So you're going to write that answer then into your table, 1.0 times 10 to the 13. And then it says that you're going to multiply these. Now, remember from the other unit that when you multiply exponents that have the same base, so this all has the same base. There's a base of 10 here and there's a base of 10 here. So actually when you multiply those, you're really just adding them. So you're going to add the exponents together, just the exponents. So negative 1 plus a negative 13 ends up giving you 14. And then multiply this. So 1 and 1 is going to be 1, right? So you end up with 1.0 times 10 to the negative 14th. That's your answer. And then it's asking you, is it an acid, is it a base, or is it a neutral? Well, you should know again by looking at this picture because there's so many more high H plus ions that it would be a base, or an acid, I'm sorry, it would be an acid. So that's what you're going to fill in here. What you should ultimately see is that all of these are going to end up with an exponent of 14 or negative 14. And this is important because if you think about what the pH scale is, the pH scale is 1 through 14, right? So these should add up to a total of 14. So you're going to continue to go through that and you're going to answer the questions, all right? So as you look at the data that you've collected, and then you're going to kind of do the same thing down here. Now down here it's going to get a little trickier because you're going to have a little bit more numbers. So again, we can do this first one together. So let's take 2.9 is where we want to be, is I think the first example. So we'll kind of move it up here. Okay, so again, you're going to write in your values here. So there were, let's see, 1.0 times 10 to the negative third. Let's just put that in there, 1.0 times 10 to the negative third. That's the concentration of H pluses. And then there was 9.8 times 10 to the negative 12 hydrogen ions. So really what you're going to do here then is you're going to multiply these across. You can just pull your calendar up or your calculator up on your computer if you want, or else use your own. So depending on which you're using, will these functions all look a little different. So obviously after the last unit you should know how your calculator works. But so go to scientific, and then you would take 9.8 times, let's see, 10 to the negative 12, so it would be 12, right? And we're going to multiply that by 1.0 exponent 3 negative, and we're going to end up with this number here. So again, it's a big number, but if you move the decimal, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We would then end up with 9.8 times 10 to the negative 15th. Okay, because we want to put the decimal between the 9 and the 8. And the shortcut way that you can do this is that you can actually just multiply 9.8 times 1. That's going to give you the 9.8. And then again, just like you did up here in this column, you're just going to add the exponents. So then you can just take negative 3 plus negative 12, and that gives you negative 15. So that's an easier way to do it if you don't have a scientific calculator handy. And again, looking at the picture, you know that this is an acid because you have all of these more red dots, these H pluses, than you do the blue dots. So hopefully that helps you answer the questions. If you have any other questions, don't hesitate to ask.